Hello students, today let us start a new chapter, that is polymers. So what are these polymers? So actually whenever we look around us, everything, generally maximum thing consists of these polymers. So this board consists of polymer, this pen consists of some polymer, this cloth consists of some polymer. So actually what is polymer? So polymers are macromolecules, consist of some repeating units. So these are macromolecules having high molecular mass. Macromolecules having high molecular mass consist of some repeating units which are formed by combination of some simple units by chemical bond. Okay, so polymers are, so these are repeating units which are formed by some simple molecules through chemical bond. So polymer are macromolecules having high molecular mass, consist of some repeating units of simple molecules having which are bonded by some chemical bond. Okay, so the simple molecules which repeat itself, the simple units which combines to form this polymer, the simple units or the simple molecule which combines to form this polymer, that are known as your monomers. And the process by which monomers are converted to, these monomers are converted to polymers, the process by which monomers are converted to polymer is known as polymerization. The process is known as polymerization. Okay. For example, look here. You have listened the name polythene. So polythene is the combination of ethene or ethylene. So when large number of ethylene molecules combine, this is ethylene. When large number of these ethylene molecules combines or undergo polymerization, it forms polythene. This is polythene. So this is known as your monomer and this is known as your polymer. And this unit is the repeating unit. In the polymer, this is the repeating unit. And large number of ethylene molecules undergo polymerization, it forms polythene. Okay. And depending on what are the type of monomer, these polymers are two types. One is known as your copolymer, another known as homopolymer. If any polymer consists of only one type of monomer unit, that is known as your homopolymer, and it consists of two or different monomer unit, that are known as your copolymer. Okay, the examples of that we will discuss later. Next come to classifications of polymers. Classifications. So polymers are classified in different ways. Number one, depending upon depending upon the source of availability depending upon type of polymerization. Before going this, okay, depending upon type of polymerization, depending upon structure, depending upon molecular forces. Attraction. Intermolecular forces of attraction. Okay, so these are classified into different types. Let us discuss one by one. First, depending upon source of availability. So, depending upon the source of availability, polymers are classified generally into three types. We can say two types actually. One is natural polymer. And another synthetic polymer. So natural polymer which are available in nature, generally that are found in animals and plants. Natural polymer found in nature, that is from animal and plants. These are generally the source is animal and plant. For example, starch, glucose, starch, this is a polymer of glucose. Similarly, cellulose, protein, nucleic acid, then starch, cellulose, protein, nucleic acid, natural rubber. Okay, so these are the examples of some natural polymers. But the natural polymers availability is less. So in this way it required some synthetic polymer. And the synthetic polymers that are known as your man-made polymers. The polymers which are prepared synthetically, that are known as synthetic polymers or man-made polymer. These are the common polymers, you know, that is your polyvinyl chloride, then polythene, then PAN, then bakelite, then polyester. So these are nylon 6. So these are some examples of synthetic polymers. Besides this natural polymer and synthetic polymer, there is another type of polymer we can also say, that is known as your semi-synthetic polymer. So what are the semi-synthetic polymer? Actually these are derived from natural source but modified by some chemical process. So these are actually the source is some natural polymer but modified by some natural process. For example, some semi-synthetic polymers are cellulose acetate, also known as rayon. For fabric purpose this is used. Then cellulose nitrate, vulcanized rubber, So these are examples of some semi-synthetic polymers. Next come to how these are classified depending upon the mode of polymerization. Next, classification depending on the mode of polymerization. So in this way, depending upon the mode of polymerization, these are classified into two types. One is known as your addition polymer and another known as your condensation polymer. Okay, I am writing here addition polymer and condensation polymer. So the polymers which are formed simply by addition reaction of some simple molecules having double or triple bond. The polymers which are formed by addition reaction of some simple monomers having unsaturated double bond or triple bond, that are known as your addition polymer, which is formed only by addition reaction without elimination of any simple molecules. So the polymers which are formed by addition of simple molecules without elimination of any simple molecules, and generally these monomers have some double bonds or triple bonds, that are known as your addition polymer. For example, polythene. So polystyrene, polystyrene, then bunna S, bunna N, all are examples of addition polymer. Polythene, you know, suppose n number of molecules, CH2, double bond, CH2. So this n number of molecules will undergo addition reaction. So this bond breaks, it contains a double bond. So this double bond generally breaks and it undergo polymerization. To form in this way n number. So this is your polythene. Simply addition. One molecular, this one breakdown. So either this reaction takes place by free radical mechanism, or this reaction takes place by formation of carbocation, carbanion intermediate, carbocation, carbanion, or free radical intermediate. And generally chains are formed. So in this way, this type of polymer are also known as chain growth polymer. These are also known as chain growth polymers. So polyvinyl chloride, then polytetrafluoroethylene or Teflon, then bunna S, bunna N, polystyrene, neoprene. So these are examples of some addition polymers, which is formed simply by addition reaction of simple molecules having unsaturated bonds, double bond or triple bond. Next, what is condensation polymer? So condensation polymers are those which is formed by the condensation reaction. So condensation polymers are those which is formed by the condensation reaction between two molecules having two different molecules having bifunctional group. So condensation polymers are formed by the polymerization of different molecules having bifunctional group. by elimination of simple molecules like water, alcohol, ammonia, etc. Okay. So these condensation polymers again classified into two types. One is known as your homopolymer and another known as your copolymer. These addition polymers are again classified into two types, homopolymer and copolymer. What are homopolymer and copolymer? We will discuss later. So you know this addition polymer. Next come to condensation polymer. So condensation polymer, suppose we look at the examples of nylon 66. So nylon 66. This is one condensation polymer of what? One is hexamethylene diamine NH2 CH2 whole 6 NH2. It has a bifunctional group, and another molecule. This is adipic acid CH2 4 COOH. So n number of this molecule, and again n number of adipic acid plus n number of adipic acid. This is hexamethylene diamine. Hexamethylene diamine, and this one is adipic acid. So these contain bifunctional group. So what happens here? H2 and here one oxy. So here H and here one OH. So not H2. Look here. This is NH2. So hydrogen and here OH. Removal of this water takes place. So it forms what? Similarly, in this side also one hydrogen and another OH part, and in this side one OH and another hydrogen part. So this is one amine and acid, an amine and acid. So hydrogen from amine and OH from acid, hydrogen from amine and OH from acid. In this way, removal of water molecule takes place. If you take n number, then 2n minus 1 number of water molecule. Removal of 2n minus 1 number of water molecule takes place, and it forms NH CH2 whole 6 NH CO CH2 4 CO. Again this unit contain NH. So in this way, this is the repeating unit and this process is continued. Okay, so this is the repeating unit. This is known as your nylon 66, and small molecules are formed. So the polymers which are formed by combination of simple molecules having bifunctional group by elimination of small molecules like water, alcohol, ammonia, etc. are known as your condensation polymers. And what are the example of condensation polymer? Nylon 66, nylon 610, bakelite, next polyester, etc. So these are some examples of condensation polymers. And this condensation polymer is also two types. One is known as your homopolymer, another known as your copolymer. So if the different monomer units are formed, this is known as your copolymer. So this is known as your copolymer. So this is a copolymer because two different units are there, two different monomers are there. One is hexamethylene diamine, another adipic acid. And another condensation polymer is nylon 6. Another condensation polymer is nylon 6, which monomer is caprolactam, where the monomer unit is caprolactam. And this nylon 6 is a homopolymer because it consists of only one monomer, that is your caprolactam. Okay. Again, these condensation polymers are also called step growth polymers. The addition polymers are called chain growth polymers because they increase the chain and generally chain reaction takes place, and these condensation polymers are known as step growth polymers because this reaction takes place stepwise. First elimination of this water and this polymers are formed stepwise. That's why this is known as your step growth polymer. The condensation polymers are known as step growth polymers and the addition polymers are known as chain growth polymers because this reaction that takes place by chain reaction. So the addition polymers are again of two types, that is your homopolymer and copolymer. So addition polymers are two types. Addition polymers, these are two types. So what are these two types? One is copolymer and another homopolymer. So which consists of only one type of monomer. These are known as your homopolymer. And copolymer, which consists of two or more different monomers, monomer units, which consist of two different monomer units, are copolymer, which consists of only one type of monomer unit, are known as your homopolymer, addition polymers. And this polyvinyl chloride, polythene, so isoprene, so these are polytetrafluoroethylene, polytetrafluoroethylene. These are examples of some homopolymers. Whereas this consists of your Bunna S, Bunna N. So these are examples of some copolymer. Here the monomer unit is vinyl chloride. Here the monomer unit is ethene or ethylene. Here the monomer unit is isoprene, but this is polyisoprene. So polyisoprene is natural rubber, and polytetrafluoroethylene, here the monomer unit is tetrafluoroethylene, and here the monomer unit is butadiene and styrene, butadiene and styrene, and this takes place in presence of sodium. That's why this is known as your Bunna S. Similarly, Bunna N, here the monomer units are butadiene, 1,3-butadiene and acrylonitrile. Acrylonitrile and butadiene. So these are your addition polymers. So this is based on types of polymerization. Next come to structure, depending upon structure of polymerization. So depending on the structure of polymerization, depending on structure structure of polymers. So depending upon the structure of polymers, these are classified into three types. One, linear polymer. Branched chain, linear chain polymer. Linear polymer, we can say linear chain polymer. Branched chain polymer. And another cross-linked polymer. Okay, depending on the structure, these are classified into three types. So linear chain polymer. So these are long chain linear polymers. So these are polymers which have long linear chains that are known as your linear chain polymers. And different polymer units here remain one above another. In this way, they have high density, high tensile strength, high melting point, high boiling points. So they have linear long chain polymers. So these are remain one above another. In this way, as they remain one above another, these are closely packed. So as they are closely packed, so they have high density, tensile strength, melting point and boiling point. Okay, then branch chain polymers. So these are long chain polymers having some linear chain and with some branch chain. They have also some branchings. So due to this branching, so these are the chain compounds and these are some branchings. So these are linear chain compounds with some branching. So due to this type of branching, now these are not closely packed. So due to linear chain structure, these are closely packed and these are not closely packed. In this way, they have low density, low tensile strength, low melting point and low boiling point. Okay, so the linear chain polymers are your polyvinyl, polythene, that is your high density polythene, polyvinyl chloride, nylon 6. These are the nylon 6,6. These are the examples of some linear chain polymers. And branch chain polymers, these have low melting and boiling points. These are the examples of some biopolymers like starch, amylopectin, glycogen, that are starch, amylopectin, glycogen, etc. So these are the examples of some branch chain polymers. Next, cross-linked polymers. So actually these form some linear chain polymers, and these linear chain polymers have also some different functional groups. They have also some different reactant sites, so that the different linear chain polymers again react with each other to form a cross-linked structure. Like so, first linear chain, and they have also some reactant sites, some 3-dimensional or 2-dimensional reactant sites. So in this way, 2 or 3 reactant sites. In this way, they combine with another linear polymer in 3-dimensional network. To form some cross-linking structure. So in this way, it can have some cross-linking structure in 3-dimensional way. So these are known as these are hard and rigid. These have also, so these are hard and rigid, and these have also high melting point. Okay, so these are the cross-linked polymers. So on the basis of structure, classified into three types: linear chain polymer, branch chain polymer, and cross-linked polymers. And these are three-dimensional network structure, 3D network structure. Okay, what are the examples? That is your bakelite, melamine formaldehyde, melamine formaldehyde, urea formaldehyde, so these are some examples of cross-linked polymers. Next, come to another type of classification, that is based on intermolecular forces. So classification based upon intermolecular forces. Based upon intermolecular forces of attraction. So these are classified into four types. One is elastomers, fibers, thermoplastics, thermosetting. So, classification based upon intermolecular forces of attraction. These are classified into four types: elastomers, fibers, thermosetting plastics, and thermoplastics and thermosetting polymers. So, what are these? Actually, what is the intermolecular? So, you know there are different polymer units. So, different polymers unit, again they come closer each other due to intermolecular forces of attraction, and the intermolecular forces of attraction are generally due to hydrogen bonding. Due the intermolecular force between different polymer units is one is hydrogen bond or van der Waals force of attraction or van der Waals force. So, in elastomers, the different monomer units have generally weak van der Waals force of attraction. So, due to weak van der Waals force of attraction, and another thing, in elastomers, it also contains some branchings, some very few cross-linkings and also some branchings. Okay, so in this way, these are not closely packed and they have a very low van der Waals force of attraction. In this way, they can be easily stretchable, and due to presence of some cross-linking between them, again it can come back to its original shape. So, example of elastomer is vulcanized rubber. Generally, rubbers are elastomers. So, these are rubbers. elastomers rubbers. And there is some in few cases it contains some branching, and in few cases it contains some cross-linking. So that is your vulcanized rubber. So due to presence of this vulcanization, some sulfur atoms are present as cross-linking in rubber. Some sulfur, this is vulcanized by adding sulfur. Due to this presence of sulfur, it regains its shape. So when some stress is applied, so it can be increased, so it can become more tensile, and after regain its stress, again it comes back to its original shape. So these are elastomers. They have weak van der Waals force of attraction. Okay. Next come to fibers. In case of fibers, the force of attraction between the polymer units is strong, and that is due to hydrogen bonding. So this is due to strong hydrogen bonding or a dipole-dipole interaction, either hydrogen bond or due to dipole-dipole interaction. So due to these two types of force of attraction, the magnitude of force of attraction is more. Hence, the fibers, in case of fibers, the force of attraction is more. And due to this, it has fibrous-like structure, and these are used for ropes, for manufacture of ropes and clothes like this. Okay, so these are your fibers. Next, thermoplastics. So what are thermoplastics? So the thermoplastic thermosettings, the force of attraction lies in between elastomers and fibers. So they have weak intermolecular force of attraction, they have strong intermolecular force of attraction, and in this case these have force of attraction in between elastomers and fibers. In this way, what are this difference between thermoplastics and thermosetting polymers? So thermoplastics, so generally these are formed in different form, and when these are heated, it becomes soft, and on cooling it becomes hard. So repeatedly when we heat it, it becomes soft, and again on cooling it becomes soft. In this way, it can be molded into different shape and can be reused. And it can be remolded into different shapes and can be reused. So these are your thermoplastics. Your polythene, polyvinyl chloride, these are the examples of thermoplastics. And thermosetting polymers, actually these polymers are in semi-liquid form. So these polymers are in semi-liquid form and in fluid form, and when these are heated, it becomes hard. So due to cross-linking, thermoplastic polymers are somehow like fibrous. It has the same type of nature like that of fibers. But the thermosetting polymers, due to this cross-linking, it become hard. At first, it was a semi-fluid substance. When it is heated, it becomes hard. And again, on heating, it cannot become soft. So in this way, after once it's set to a hard structure, it cannot be remolded and cannot be again reheated and cooled. In this way, this is called thermosetting polymers. Once it's set, we cannot change its structure or composition, but we can change its structure. In this way, this is known as the thermoplastics, and this is your thermosetting polymers. And the force of attraction, the magnitude of force of, and what are the thermosetting polymers? Your bakelite, formaldehyde resin, and urea formaldehyde resin, and melamine formaldehyde resin. These are the examples of some thermosetting polymers. So the magnitude of force of attraction between these four is, what are the different types? So first, the strong force of attraction is first fibers, then Thermoplastics, then Thermosettings, then elastomers. Okay, so these are your different types of classification. Next come to process of polymerization. So the process by which the polymers are formed is known as polymerization. The process by which the polymers are formed is known as your polymerization. And this polymerization is two types. One is addition polymerization and another condensation polymerization. So polymerization process is two types. So the polymerization which takes place by simple addition reaction between different molecules. So the polymerization which takes place by simple addition reaction between different molecules is known as your addition polymerization. And I have told you in addition polymer, that is in addition polymer generally the monomer unit contains double bond or triple bond. These are unsaturated hydrocarbons. And in condensation polymer generally the process by which the polymerization which takes place by condensation reaction by the combination of some molecules. If small molecules like water, ammonia, alcohol, etc. are removed, that reaction is known as a condensation reaction. So the process by the polymers which are formed by the polymers which are formed by the condensation reaction of different monomer units is known as a condensation polymerization. This is also known as step growth polymerization. Step growth polymerization. And this is known as your chain growth polymerization. Okay, so today we know what are polymers and what are different types of polymers. Next class we will discuss some examples of polymers.